Good afternoon, my seventh hour. See, you can't get rid of me even though I'm not here. You get to listen to my crazy voice. Um, so today what I want to do is I want to show you a little bit about acids and bases and some calculations. So first thing we want to do is get to your notes, and right here it says water is an acid and a base. So amphoteric, that's how you say that, amphoteric. Amphoteric means that a substance can behave as both an acid and a base. And if you recall, when we're going through and classifying all of our acids and bases, we have the Arrhenius theory, then we had the Bronsted-Lowry theory, and then we had the Lewis acid-base theory. So again, we just don't have the best way to classify these. And it works. Some theories will work for one and not another, but this one we're going to talk about amphoteric as the ionization of water. Ionization meaning that how it breaks apart. And so if I take two water molecules and simply write down this equation here, you will see how water is acting as both an acid and a base. So just we've been doing earlier in the chapter, we are bracketing these things together so we can see and focus on the half reaction as to what is going on. So if I take my first one, you can see that I have 2 hydrogen here and I have 3 hydrogen. So that has been an acceptor. So that is a proton acceptor, so that this makes it a base. And remember, its partner is an acid or connected together as a conjugate acid. And here, this hydrogen has 2 in that form of water, and over here I have 1. So it has lost 1, so this has donated because it's a proton donor, and this is its conjugate base. So you can see in both instances that I have water acting as a base or an acid. So we get a constant for this in this formation so that we can use it to determine pHs and whether something's acidic or basic. So the Kw is equal to our ionization constant for water, and that is on one of your gold sheets, so we'll talk about that in a second, is equal to your hydrogen ion concentration times your hydroxide ion concentration, and the constant is 1.0 times 10 to the negative 14th. So we're going to use this so that we can determine if something is acidic or basic. Okay, so moving on to the next thing for that pH scale that I've been mentioning, and we're going to look here that it says the P scale is used to express very small numbers, and I know that some of you have mentioned yesterday that you're not super comfortable with using logs, but that's as difficult as it's going to get in here as just punching it in your calculator. So we have the pH is equal to the negative log of the hydrogen ion concentration. So again, when you see those brackets, it means concentration. And as we studied in the last chapter, we know that that is equal to its molarity. So if we look over here at this pH scale, you can see that it says the hydrogen ion concentration, and then it gives you its pH. So we always have to make sure that we are referencing our hydrogen ion concentration, meaning how many hydrogen are sitting in our solution. So here you can see that we have neutral is right here at 7. And then if I'm on this side of 7, greater than 7, it's going to be a base. And if it is lower than 7, it's going to be an acid. And yesterday we were talking about the acidity of rain. And if it's stronger, you can see your stomach acid is way down here. These are going to be strong acids and act very similarly to some cleaning supplies and some strong bases. So we want to do some calculations on this. Now, these are the only 2 slides that I want to cover. If you guys flip to the back page of your notes, you have a blank place. So what I want you guys to do is flip to the back so you have a clean page, and we're going to go through a couple of problems. So we're going to do example number 1. And my first question for you is, sorry, I'm going to flip it over here and find it. We are going to calculate the hydrogen ion concentration. All right, and I am going to give you the concentration of my hydroxide. And we're going to calculate the hydrogen ion concentration, and we are going to determine if I have an acid or a base solution. So if you take a look at your gold sheet that I hope Mr. Cook told you to take out, I left a few extras up here if you need them. On the bottom it says chemistry formulas. And I think you can see that it says the ionization of water is 1.0 times 10 to the negative 14th is equal to your hydrogen ion concentration times your hydroxide ion concentration. So I hope that you're looking at that and saying, oh, that's just simple algebra. I can plug that in. And that's exactly what you need to do. So this is going to be our X because we don't know what that is, but we do know our hydrogen ion concentration is 2.0 times 10 to the negative second. Go ahead and divide both sides by 2.0 times 10 to the negative second and make sure you're punching this in right in your calculator. And go ahead and solve that. And you guys can see that I have two significant figures here in my concentration of my hydroxide, so I'd have to do the same for my concentration of my hydrogen. And that's to the negative 13th. And again, that's molarity. You can use brackets or you can use the M. Now, to answer if it's an acid or a base, I'm going to take a look and pay attention to, for my basic substance of OH, I have 2.0 times 10 to the negative second. For my hydrogen, which is an acid, 5.0 times 10 to the negative 13th. This is a much larger number. All right, so this is a much larger value. So this is going to make it a basic solution. If this would have been a larger number, then it would have been acidic because we associate the hydrogen ion with acids. Okay, let's do another example. We're going to do 4 examples. So example number 2. I am this time going to give you the hydrogen ion concentration. Okay, and now what I'd like you guys to do is I want you to find the pH. Now this is going to be pretty simple, but we just have a new significant figures rule that I want to talk about. So if I do this, I am going to take, if you look right on your gold sheet, you can see that pH is equal to the negative log, as we already talked about in your notes, to the hydrogen ion concentration. Okay, so I'm going to take the negative log, so hit negative log, and then punch in 3.5 times 10 to the negative 7th. So go ahead and do that. I'll do it at the same time, so I'm giving you enough time. So I hope you're looking at this sort of number, 6.45593, keep on going. Okay, now because we're doing logs and it's based on 10, we have to do our significant figure rules a little differently. If you look up here at hydrogen ion that I gave you, I would hope that you would agree that that is 2 sig figs. Now to do pH, because it's based on 10, these 2 sig figs have to be shown as decimals in the pH. So I would write down 6 point and then I look, okay, I have 2 sig figs up here, so I need 2 sig figs down here as in the decimal area. I don't know the right way to say that, but so it's 4, 5, so this 5 is going to make that a 6, so it's going to be 4, 6 is going to be equal to my pH. So again, I hope that you can see that I have 2 decimal places to represent the 2 sig figs that are up here in my concentration. I would look at this pH of 6.46 and I would recognize that it's less than 7, so I would say that that is an acid. Okay, that is example number 2. We're halfway there. Now let's do example number 3. And you're going to see there's a variety of ways that you can get to some of these answers. And that's the hardest part about this, is how I'm going to be able to see how to get to these paths. And it just really depends on your mathematic and if you're going to use logs or not. Sorry, let's see here. I need to pause for 1 second. Okay, sorry about that. All right, a little interruption there. So now we are going to do example number 3. And for this one, I'm going to give you this time the hydroxide ion concentration, and that's 5.8 times 10 to the negative 7th. And for this one, I want you guys to find the pH, the pOH, and the hydrogen ion concentration, and tell me if it's an acid or a base. Now, like I said, if you're looking at your gold sheet right now, there is a variety of pathways that you can get there. It just really depends on what you see and what you want to do first. So to take a look at my hydroxide, I probably would do the negative log of it to get to my pH. So I'm going to say that my pOH is equal to the negative log of my hydroxide ion concentration, 5.8 times 10 to the negative 7th. And when I punch that in, I'm going to look at that I have 2 sig figs here in my concentration. So my pH, I need 2 decimal points. So this is 6.24 is going to be my pOH. And then you guys can see that the pH plus my pOH is equal to 14, which is the scale, the entire scale. So I can just go ahead and put in my numbers and subtract. So I'm going to take 14, subtract 6.24, and again I have to have those 2 decimal places behind it, so I have 7.76 is my pH. Now, to answer the question of whether it's an acid or a base, I cannot look at this one because my pH scale is not based on the pOH. It is based on my pH. So because this is greater than 7, I can say that this is a base, and it's actually a very weak base. So then the last question I have is the hydrogen ion concentration. How you get there is a variety of ways. It's up to you. You guys can see that I could take my KW and very easily get to my hydrogen ion concentration. I could take the anti-log, I think that's the right word, of my pH, but I'll do that in the next problem. So this one I'm going to do 1.0 times 10 to the negative 14th is equal to the concentration of my hydroxide, which we found was given of 5.8 times 10 to the negative 7th. So go ahead and do some algebra on this one. And again, I need 2 significant figures, 1.7 times 10 to the negative 8th. Okay, so lots of numbers, but simple math. You just have to figure out how to get there. Okay, our last problem. So this one, I have started you in different points for all 4 of these problems. So for this one, my starting point is I'm going to give you the pH, and now we're going to try to work backwards. If you've noticed, I've given you one piece of information, and we can answer all sorts of questions. So for this one, I want the hydrogen ion concentration, the hydroxide ion concentration, we want the pOH, and we want to know if it is an acid or a base. Similar questions, I'm asking all of them. We just have different starting spots. Okay, so the only place I can start with the pH is I need to recognize that my hydrogen ion concentration is equal to 10 to the negative pH. Okay, so let's substitute that in. So I have 10 to the negative 5.24. Calculate that out. I can see I have 2 decimal points there in my pH, so that means I need to have 2 sig figs in my concentration. So this is going to be 5.7 times 10 to the negative 6th, and that is going to be my hydrogen ion concentration. All right, so that's one answer. We got that one taken care of. I think to get to our OH, I would use KW again. I think that's just the easiest for me. You can do different things. It's up to you. 1.0 times 10 to the negative 14th And I have 5.7 times 10 to the negative 6th times my OH brackets concentration. So when I calculate this out, my hydroxide is going to be 1.8 times 10 to the negative 9th. Okay, so I have, let's see, what have I done so far? I have my hydrogen ion concentration, I have my OH, my POH. I think the simplest thing to do would be to take 14 and subtract the pH that I started with, 5.24. And I don't have that written down. I'm not very good at that math fast in my head. 8.76. And this is going to be our pH, no, POH, excuse me. And again, I'm not going to look at that number to tell me if it's an acid or a base. I can look up here and I can see that I have my pH of 5.24. That's going to tell me that it is an acid. And the other way that I can tell is if I look at here, my hydrogen ion concentration, 5.76, and my hydroxide, this is a larger number. So again, that's going to make it an acid. Okay, so you guys have your homework packet, and I want you guys to start working on homework number 2 here. You can see it goes right into your books, so you're going to need to grab books over on the other side of the room. So I'd like you guys to work on homework 2 and bring the questions that you have from this tomorrow. And the other thing, hopefully that Mr. Cook has told you that your acid base packet that I gave you is also going to be due tomorrow, sometime at the end of the hour. And so you'll have work time tomorrow to complete that. Okay, you guys have a wonderful day. I might be here at the end of the hour to see you. If not, I will see you tomorrow. Take care.